Cargo math. All right, welcome back, ladies and gentlemen. Today we are going to go over lesson 7.1, equations with variables on both sides. We're looking at part 1. So what that means for us is that our objective today is that you can solve equations with variables, meaning x's, y's, any letters, on both sides of the equal sign using inverse operations. Inverse operations, if you have forgotten, inverse means opposite. So, whoopsie, sorry for the zoom there. Nope, please stop doing that. There we go. Opposite. So for example, addition and subtraction are inverse operations, and multiplication and division are inverse operations. So the first thing that we have to think about is answers to equations look like what? We need to think we are going to be solving an equation where there are variables on both sides, or x's or y's. What does the answer look like? Because if I know what the answer looks like, then I can work to manipulate my equation to look like my answer. So an answer to a algebraic equation is usually a variable on one side equals a number or constant on the other. There are some other ways you can get answers. We'll talk about those in a while, but the one we're going to focus on right now is just a variable on one side and a number on the other. So what that means is if I have an equation like this, where 5x minus 2 equals 3x plus 4, I need to make sure that I get all of my variables on one side and then all my constants on the other side so that I can solve and get one answer. So this should go into your note taker. There's a box that says answers to equations look like what. Please go ahead and pause the video and copy this down for your notes. All right, so now we're actually going to dive in and solve a problem here. So on this right-hand side, I have your steps. These steps will help you figure out everything that you need to know to solve any problem that has variables on both sides. The first thing that we are going to do is we are going to gather all of our variable terms to one side of the equation. So we like to draw that line down the middle like it was on our previous slide, but that one was done with color to show our two sides. I am going to move my variable terms to just one of those sides. I can move them to either side, but remember that we like to have positive variables. So if you can keep your variable a positive number, that's probably the right way to go. So I am going to go ahead and subtract x. Remember, this is really 1x from both sides, because if I take away the smaller number from the bigger number, it will stay positive. 1x, take away 1x, leaves me with just 5 on the left-hand side. That means that over here are going to be my constant. Terms. Okay, on the right-hand side, I'm going to be moving all of my variable terms. So sorry for the typing. This guy doesn't like to write clearly. So, and now over here, if I have 3x, take away 1x, that's going to leave me with 2x's. Remember, we're literally doing 3x's, take away 1x, and I'm left with 2. That's what it looks like right there. And then I'm going to subtract 1, because this guy, that's minus 1, just goes straight down. What I now have, this new equation here, is a two-step equation, just like what we've been practicing. Okay, so my next step is now to get all those constant terms to the other side. So my variables are moved to the right, so I want to move my constants to the left. So I'm going to add 1 to both sides, getting rid of my constants on my right-hand side, and I get 2x equals 6. I now have a one-step equation. So I am going to go ahead and isolate the variable or get it alone. So to get x all by itself, I'm going to divide it by 2. That's going to turn into 3, which is my answer. All right, in our next example, we're going to do these same steps, but with this new problem. So again, the first thing I'm going to do is draw that line down that equal sign so I can see my 2 equal sides. My goal is to get all the variables to one side. So because my x's are already on the left-hand side, let's just go ahead and subtract 22x and move all the x's to the left-hand side. I am going to get 30, take away 22 is 8x on the left. And then whatever I'm left with on the right-hand side is just 48. I am now, all my constant terms are already on the other side of my equal sign, so I'm going to skip down to step 3 and isolate that variable. I'm going to divide by 8 on both sides. 48 divided by 8 is 6, and that is my answer. So now the last thing that we're going to do in this lesson is just follow those steps from above, and we're going to do that on 2 more problems. Go ahead and pause the video and try these on your own, and then come on back to the video so that you can check your work and see how you did. Go ahead, pause the video. All right, now that you've paused the video and completed the problems on your own, let's get to solving to see how you did. So I'm going to draw that line down my equal sign. This one's a little tricky because all of these x's get a little confusing, but really this is 1x on the left and negative 1x on the right. I'm going to go ahead and add my x to both sides to keep them positive. That's going to get me 2 x's because 1x plus 1x makes 2x. On the left, plus 4. And then on the right, I'm left with just minus 4. If I subtract 4 from both sides, I'm now going to get 2x equals negative 8. Then if we divide by 2, we'll get negative 4. And that is the answer to that first problem. Now, some of you may be going, but Ms. Kirkwood, I went the other way. And I added or I subtracted x from both sides, and that's okay. So even though we like our answers to or our variables to be positive, it's really just the solution, this guy down here, that we want to be positive. If you're able to keep your answer positive, but you start with a negative variable term in the problem, that's okay. I'm actually going to take some time to show you what that looks like really quickly. So let me do this problem again. But this time I'm going to subtract x from both sides instead of add. Okay? If I do that, I cancel out the variable on the left side, giving me a negative 2x on the right, minus 4. I'm still going to move that 4 over and add 4 to both sides, giving me positive 8 on the left and negative 2x on the right. Okay? Still need to isolate that variable, so I'm going to divide by negative 2, and that is how we keep our answer positive in this case, and we still get the same answer of negative 4, because negative 2 divided by negative 2 is just 1x. Okay, so it's okay to move your variable to one side or the other. It doesn't really matter. It's just if you ever get a negative x equals an answer, we don't want that. I don't want this negative right there. I don't like that. So what I have to do is do something to get rid of it. So I would multiply both sides by negative 1, and then that will change my answer to have a positive variable, and my x would equal negative 3. All right. Let's take a look at the problem on the other side here. so we're going to go ahead and do the same thing. I'm going to, I'm going to go ahead and add 3x to both sides because, again, I'm going to keep I like to keep my x's positive if possible, although whatever is easier for you makes sense. Minus 1x plus 3x makes 2x. And that minus 8 just comes on down. Okay. Now my equation is 2 equals 2x minus 8. I'm going to add 8 to both sides. Oops, sorry about my 8s. They're getting all funky. All right. 2 plus 8 is 10. 10 equals 2x. If I divide that by 2, I'm going to get, oopsies, oops. X is 5. There you go. Well, I hope you guys did them correctly, and I'll see you in class so we can practice more.